Hello to everybody. Welcome to our webinar. My name is Alexander and I have been working as a geologist more than 18 years and I'm currently CTO at Dalon. Before starting the webinar of implicit modeling versus after wireframing model, I want to tell you about the uniqueness of the Open Dalon. Actually, this is first software of its kind that every professional in our industry can use. It's open and accessible. Have you seen a lot of software that does not need to be installed on the device? That can be used even from a smartphone. Write in the chat if you meet some softwares which are the same. In my opinion, this is revolutionary advantage. Just imagine one click on the link and complete system is ready to work anywhere, anytime, and whenever you need. A bit later, I will show to you how to open the system and how to register, and you can join to our community. Yes, about communities, we just launched a few days ago a cool thing. It's our knowledge place. A place where experts can ask questions and share their experience, consult with each other about current issues. Now let's just a bit talk about what you should to expect from this webinar. Why implicit modeling is no longer relevant, what the problems it created in operation, and how the algorithms which used in OpenDalon strive to set new standards. I will demonstrate how systems work in real time, and you will see how fast and powerful it can solve complex issues. For example, what I have already talked about at the first hour webinar and my colleague in the last. Of course, in the end of the webinar, we are ready to answer to all your questions and maybe it can be some discussions. Okay, let's start. To get started, you need to register in the system. You can do this with Google or LinkedIn account, as I previously showed in webinar. Then you will have access to knowledge place and the functionality of OpenDalon. The knowledge place now it's empty, but soon we will place here interesting themes to discussion, and everybody can make some comments or see answers of other. 3D model. Now it's work in our Command 3D tool, and according to this, that this algorithm is prototype, and we are actively developing it, and those who follow OpenDalon can see it themselves. You need only three things: color, survey, and assay. First of all, color. For color, we're using CSV file which have such structure: whole ID, depth, north, east, and relative level. Survey file, it's just almost the same: whole ID, depth, azimuth, and deep. And assay file. Assay file with whole ID, interval from, interval to, and the grade. Actually, you can use other files with another structures, not only the same. After clicking OK, you can see all your drill holes in 3D. Next step, which is needed for our model, this is composites. Just clicking on composites, and you can see parameters of. Just one sec. I'm in Russian version. Okay. Compositing parameters. For this, we need two types of grades. Grade in the output composite, for example, 1% for actual case, and grade in the sample for compositing. We will take 1% in this case. Minimal length of ore and maximum length of waste. After all this, we are clicking on composite, and when we see a message that compositing data is loaded, we just pushing on the button OK. Now you can see dots on the drill holes. It means that composites are constructed or estimated, and they are appear in our at our drill holes. Next step, this is creation of the central surface. For this, we need only trend parameters, which is azimuth of strike and plunge of strike. Now we are working with like geological data. I mean geological direction of the ore body, not just statistical. And in this case, we are putting that plunge is 0. Also, we need deep of the ore body. In our system, we are working by the rule of left hand. This means that if the azimuth, like in this case 123 degrees, deep will azimuth of the deep will be 90 degrees plus. In this case, 213. Then we need parameters of the searching. In this case, strike searching 200 meters and deep and search for deep also 200 meters. And tolerance. Now it's only 5 degrees of tolerance, but we can put here, for example, 15 degrees of tolerance. And after this, we just pushing button build middle surface, and when the message will appear that process is done, we can just push OK. Now we have our database with middle surface, which is built through every composites. If you see some composites which are not have central surface, it's okay, because our body was not founded in other neighbor composites or drill holes. After this, we need to make wedges or inclines. I'm not sure how it will be in English, because it's no any actual term. I didn't find it yet. This is next button, and now we have incline settings. There is 11 different parameters, like minimal or width. For example, we used 10 meters. It means that if the ore body in the actual composites will be more than 10 meters, it will be one rule, and if it will be less than 10 meters, it will be another rule. And we have actually two types of inclines. This is bounded inclines and unbounded inclines. Bounded inclines, it means that we have a drill hole which is drilled near the orbit but do not intersect this orbit. And unbounded inclines when we have no any information after the last intersection by the orbit. And how it works. If we have orbit less than 10 meters, we can put how much will be length of the incline. Here is we used 0.5. It's like half distance between drill hole which is intersect orbit and drill hole which is not intersect orbit. And we using also we have a parameter of the width of incline. It's mean how which width will be used for boundary of the orbit. If we have width in the composite less than 10 meters, then it will be dot or 0. We can actually put here 0.5 or YTC. Next step, the same for unbounded incline. Unbounded incline depends from your searching parameter. If we took 200 meters and here we put it 0.25, it means that it will be quarter of our strike. And the same if width of composite less than 10 meters, it will be inclined on the dot. And same for second portion, like if we have minimal width more than width of composite more than 10 meters. In this case, bounded incline will be made for half distance, and width of the border will be half of the composite. And same for unbounded incline in the case when when the width of actual composite more than 10 meters. When we put all these parameters, we are pushing generate inclines, and then we can see at our model that we have two different middle surfaces. One which is interpolated between drill holes, and second one which is extrapolated for drill holes. And drill holes which has only one intersection, I mean when it was like lenses, they are buried in inclines. Actually, here you can make any sort of sections and can see what is actually happens. Now it's prototype, and soon we will update with some interesting tools. One of these is editing of central surface, and I will explain for what we are doing it a little bit later. And last step, we should to generate wireframe. When we push in closed meshes, our orbits are generated. Actually, you can just use all these models in another software, or some later you can use it into the our software for resource estimation. Also, you can use multi-trend or different trends for working with this algorithm. For now, multi-trends assess format of multi-trends are 3D mesh. But later we will add possibility to use other formats for using of dynamical trend. And actually, you can just create your dynamical trend into our software, and in next webinars I will show how you can make it, or my colleague will show it. It depends. Okay, just let's hide all information and leave only our dynamical trend. How it's used? You can make middle surface when you upload your dynamical trend, and you can push build middle surface as well. And when you have message that it's done, you can see that you have another portion of central surfaces. Let's check our central surface previous without dynamical trend and current model with new central surface. They are a bit different because central surface is affecting it on the central surface, where dynamical trend is affecting on the central surface. Okay, next step is same, incline settings and creating of inclines and closing of the meshes. As you see, algorithm works is very fast. It's not need to have big resources of the computer for working with it. Why did we choose this concept, and what are its advantages? First of all, its controllability of the process. As I said before, we are preparing a set of tools to be able to edit, merge, separate of the central surface. This is necessary because no any geostatistic which can define a deposit without any certain errors. It's like when you're trying to make one good geostatistic or geostatistical research. It means that sometimes in some portions of the orbit it will be overestimated, and in the same time in another portion it will be underestimated. How it will works? The work will be done by the like one flow. You're just creating central surfaces, you're just editing them, then inclines and generating of the wireframes. Second, very interesting point, that event accuracy. Very often when you're using geostatistic tools, it can Implicit modeling, which is based on GSTC tools, can make blobs between intersections or decreasing of the thickness of the orbit. Our algorithm is precisely follows the logic of the intersection. I just will show it to you. Just one sec. We'll take something like not very it means that you have a regular width which is based on the other intersections, which is placed near the orbit. And third portion, it's a small model size and resource optimization. I mean resource of the processing optimization. Implicit models usually have a large number of the triangles, and updating them is essentially a recalculation of the whole model, which requires large processing resources. In our case, as you can see, the model do not have a large number of triangles, and we will take care about to not rebuilding of the model completely when the database is updated. And last, it's just statistic. In our algorithm, you do not need to know the statistic as a discipline. I mean that if you're using some tools, you should know how it's work and which functions that algorithm is using, and not only the functions, but also the base of this function and how it can depend, how can it affect on your orbit. I mean function square in square or in cube, and how it will be affect. It will be longer orbit or shorter or something like that. After wireframing model using only intersection data, and it's understandable for every graduated geologist because we're using only strike and its azimuth and deep and its azimuth, and this all what you can take with the compass. Okay, if you have some questions, you can ask in chat, and I'll try to answer on these questions. The question from Dmitry. Yes, actually, you can use. Okay, now I will show it to you. This trend surface have several trends. Okay, now I should do this dynamic trend have several surfaces. And yes, you can use different dynamic trends. Actually, you can use as many different surfaces for dynamic trend as you want. Okay, we are waiting next questions, and I will tell a bit about our next steps of development. In some future, I mean next week, we will update this algorithm at Delon Pro, and also in few weeks we will make additional 3 very valuable updates, and this will increase time for modeling in several times for every deposit, for maybe most of the deposits, and our goal to make tool for modeling which will be work with from PC or tablet or phone, and the main goal to make a tool which will be lighter than implicit modeling tools, but with increasing the processing time and modeling time, maybe for few hours or even few minutes for every type of deposit. Then follow us, follow Delon Pro, and you will see changes. If this question can be actually, if you mean if dynamic trend have much more surface than non-implicit, it's not issue for the software. I mean, you can use dynamic trend which is generated by another software which is using implicit modeling, or you can even try to use surface which is created in Delon with tool for surface construction, because it uses different type of different algorithms like Poisson algorithm, and it will be with plenty big number of triangles. Yes, you can use it. And if you asking about do we want increase triangles in our model, yes, at next steps for geology we will make another algorithms, and we will make our models for just geology modeling more smooth. I don't know, did I answered on your question exactly? And also, with development of our web portal, I mean website, and with development of this algorithm, we will put other possibilities for dynamic trend, as for example, numbers of just strings, or numbers of just ellipsoid of searching, and etc. And we'll add some tools for just more usable, for more friendly using. And actually, all this, what you want and what you expect, and maybe some ideas, you can just put on our knowledge place. It will be appreciated to see at our knowledge place some activity from expertise from experts in the industry. Thank you very much, Dmitry. Then, if no any question, I want to say to you all thank you, and we'll see, we'll catch up at next webinar. Thank you very much. Cheers. Bye.